So, we've already established that F represents between group variance. In fact, it represents the true or real between group variance after we take into account the within group variance, or the amount of variance that each group brings to itself. I used this handout before. I'm going to refer to it again, but this time I'm going to refer to this right here at the bottom, F. F. So how we calculate F, or how we find F, is we take, based on all the words that I've already shared on this sheet, but also in the earlier YouTube clip, we take the between group variance, also known as MS between, MS sub between, and that MS stands for mean square. I know there's a lot of vocabulary here, but it really just means, mean square simply means the total or raw between group variance. That's all it means. So we take the total or raw between group variance, or mean square between, and then we divide it by the within group variance, also known as MS sub within, or mean square within, or aka the error term. And I know that's a lot. So again, if you need to rewind this or start this YouTube clip over in order to try to lock that in, please, please, I implore you to do that. So F equals the total or raw between group variance and divided by the within group variance. And that's essentially this ratio right here. This ratio right here is reflective of this statement here. These two things, believe it or not, this statement here, it says the exact same thing that this statement says, or this equation, this symbol says. F represents the total or real amount of variance between our groups after we take into consideration the amount of variance each group individually brings to the table on its own. F represents the between group variance divided by, or taking into account, the within group variance. Or to refer to an earlier drawing, graphic, we've got within group variance, we've got between group variance, and when we take within group variance into account, the amount of between group variance that's left over is what we need to observe and compare to the probability distribution. Now, let's see. F tests are going to involve the comparison of a data generated F to an F value from the F table. Now hopefully that language sounds familiar, because that's exactly what you were doing with a t-test for one sample. Likewise, it was exactly what you were doing with a t-test for two samples, right? You calculated a t-value, a data-generated t-value. So you calculated that data-generated t-value, and then you essentially compared it to the appropriate t-value from the t-probability distribution. Well, guess what? That is the exact same thing you're going to be doing with f-tests. The exact same thing you're going to do with f-tests. You're going to compare a data-generated f-value to the appropriate f-value from the f-table. Now, as we've already established, data-generated f is the amount of between group variance or difference that we actually observe. Generally speaking, that's how we can refer to data-generated F. Data-generated F is the amount of true between group variance or difference that we actually observe. Tabled F, and this is very important. So again, this is one of those very important statements. So if you want to rewind and go back and listen to it a bunch, please do that. Tabled F is the maximum amount of between group variance that we could expect to observe given certain conditions. And those conditions are, we'll go over this again later on, the number of groups that we're comparing, so the number of groups in our analysis. Think back to the hypothesis sheet that we were going over, and I made a point of trying to define or emphasize the number of groups that were represented in those hypotheses. So tabled F is the maximum, tabled F is the maximum amount of between group variance we can expect to observe given certain conditions. The number of groups in our analysis, the total number of cases in our analysis, and the rigor of our test. Now, little spoiler alert for you. Using the information that is in SPATS, there are only two options for the rigor of your test. It's either a .05 test or a .01. That's it. There's no .02, there's no .10, there's no, and in fact, also by the way, there's no tails. You do not have to make a decision about whether you need a one-tailed test or a two-tailed test. There's only one option, which we'll get to in a little bit when we begin to discuss the probability distribution itself. But for now, I want you to be aware of what an F value represents. It represents between group variance. More specifically, it represents the total raw amount of between group variance divided by the within group variance. So that's what F represents. It represents what's left over, the between group variance that's left over. Also, F tests are going to involve the comparison of data generated F to tabled F, okay? And data generated F is the actual amount of between group variance that we observe. Tabled F comes from the table, and specifically tabled F represents the maximum amount of between group variance we could expect to occur by chance alone, by chance or sampling error or accident alone given certain conditions. What are those conditions? Those conditions are the number of groups in our analysis, the total number of cases involved in our analysis, and the rigor of our test, whether we're doing a .05 test or a .01 test. All right. So, just as a little look ahead here. How many groups are involved in this analysis if this were a real exercise? How many groups? 3, right? What is our total N for this analysis if we were to use these data to actually put them to the test? What's the total N? The total N is simply, or N sub tot, N sub TOT, N sub tot. The N sub tot, or the total number of cases, is simply the sample size for group 1 plus the sample size for group 2 plus the sample size for group 3. So in this case, we've got 1, 2, 3, 4, 5 in group 1, 1, 2, 3, 4, 5 in group 2, 1, 2, 3, 4, 5 in group 3. So 5 plus 5 plus 5 is 15. Also, we'll go over this in a later clip as well, but in ANOVA, the number of groups in your analysis is referred to as K, simply the letter K, specifically lowercase k. So the number of groups in this analysis is 3, group 1, group 2, and group 3, which means there are 3 groups involved in the analysis, which means k equals 3. Also, as we've already established, the total number of cases involved in this analysis is 15. 5 cases in group 1, 5 cases in group 2, 5 cases in group 3, 5 plus 5 plus 5 is 15. So N sub tot for this example would be 15.